We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
I feel the liftoff. The clock has started. Roger.
This is a new and strange environment at first. Just suddenly finding yourself in orbit.
We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11. Houston, Tranquility Base here. The Eagle has landed.
Hello and welcome. This is Michael Annis, and you're listening to episode 36, the Halloween edition of the Space Rocket History Podcast. And now, Mariner 2 and Relay 1. During the summer of 1962, final preparations were underway for the first U.S. attempt to reach another planet. The planet was Venus, Earth's closest planetary neighbor. This first flight would be accomplished by the JPL-built Mariner 2 spacecraft. Mariner 2 was actually the second of a series of spacecrafts used for planetary exploration in the flyby mode, without landing. The first Mariners were designed and built on an extremely demanding schedule. JPL had to ready 3 probes, 2 to fly to Venus and 1 spare, in less than 1 year, with strict weight limits. Only 40 pounds was available for scientific equipment. Getting to Venus was no easy feat. The Soviet Union suffered several failures in their attempt to get to Venus in 1961. In order to speed things up, Mariner 2 was based on a Ranger spacecraft. That was covered, you remember, back in episode 32. Mariner 2 was actually a backup for Mariner 1, which began to fishtail shortly after launch. The fishtailing was so bad, the range safety officer pushed the self-destruct button 4 minutes and 53 seconds into flight. Here's the clip.
Mariner 1 blasted off the launch pad on July 22, 1962. At first, all went according to plan, as the Atlas rocket accelerated through Mach 1, 2, and 3. But then, the Atlas began fishtailing and veering off course.
We're not on trajectory.
This is range safety. Stand by.
Mariner was only seconds away from separating from the errant rocket when the range safety officer had no choice but to give the destruct command.
Destruct command. Repeat, destruct command.
This one apparently blew up.
Analysis showed that the cause of the rocket failure was a software error. A single misplaced symbol of code had resulted in the loss of the first U.S. spacecraft destined for another planet.
The objective of the Mariner 2 mission was to fly by Venus and return data on the planet's atmosphere, magnetic field, charged particle environment, and mass. It also made measurements of the interplanetary medium during its cruise to Venus and after the flyby. The Mariner 2 spacecraft was designed and built by the Jet Propulsion Laboratory, JPL, based on a Ranger block. Physically, it consisted of a hexagonal base, 1.04 meters across and 0.36 meters thick, which contained 6 magnesium chassis housings for the science experiments, communication equipment, data encoding equipment, computing equipment, timing equipment, attitude control equipment, the power controller, battery, and battery charger, as well as the attitude control gas bottles and the rocket engine. On top of the base was a tall pyramid-shaped mast on which the scientific experiments were mounted, which brought the total height of the spacecraft to 3.66 meters. Attached to either side of the base were rectangular solar panel wings with a total span of 5 meters and a width of 0.76 meters. The solar panels were used to power the craft directly or recharged a 1,000 watt-hour battery, which was used before the panels were deployed and when the panels were not illuminated by the sun and when loads were heavy. A power switching and booster regulator device controlled the power flow. Attached by an arm to one side of the base of Mariner 2 and extending below the spacecraft was a large directional dish antenna. Communications consisted of a 3-watt transmitter capable of continuous telemetry operation, the large high-gain directional dish antenna, a cylindrical omnidirectional antenna at the top of the instrument mast, and 2 command antennas, one on each end of either solar panel, which received instructions for mid-course maneuvers and other functions. The total mass of Mariner 2 was 202.8 kilograms. Propulsion for mid-course maneuvers was supplied by a monopropellant 225 Newton retro rocket. The propellant was ignited using nitrogen tetroxide and aluminum oxide pellets, and thrust direction was controlled by 4 jet vanes situated below the thrust chamber. Attitude control with a 1-degree pointing error was maintained by a system of nitrogen gas jets. The Sun and Earth were used as reference points for attitude stabilization. Overall timing and control was performed by a digital central computer and sequencer. Thermal control was achieved through the use of passive reflecting and absorbing surfaces, thermal shields, and movable louvers. Only 40 pounds or 18 kilograms of the spacecraft could be allocated to scientific experiments. The scientific equipment included a magnetometer to measure planetary and interplanetary magnetic fields, particle detectors, a cosmic dust detector and solar plasma spectrometer to measure the spectrum of low-energy positively charged particles from the Sun, i.e., the solar wind, a microwave radiometer and an infrared radiometer to measure the effective temperatures of small areas of Venus. A cosmic ray detector was used to measure high-energy cosmic radiation. All the instruments were operated throughout the cruise and Venus encounter except the radiometers, which were only used in the immediate vicinity of Venus. With all the scientific equipment aboard and limited weight, a camera was not installed. The launch vehicle used for Mariner 2 was an Atlas Agena, very similar to the one used on Ranger 4. You may recall from episode 32, the Atlas Agena was a 2.5-stage rocket with a 1.5-stage Atlas missile as the first stage and an RM-81 Agena second stage. Mariner 2 was launched from Cape Canaveral Air Force Station, Launch Complex 12, on August 27, 1962. Here's the clip.
August 26th, the Mariner 2 countdown begins. Events move on a strict timetable.
5, 4, 3, 2, 1.
Shortly after liftoff, the rocket began to roll, making it unable to respond to guidance commands. In the first of a series of Mariner miracles, the electrical short causing the issue mysteriously healed itself about 1 minute later. 5 minutes after liftoff, the Atlas and Agena Mariner separated, followed by the first Agena burn, which placed Mariner in a 118-kilometer altitude Earth parking orbit. 16 minutes later, the Agena second burn and separation injected the Mariner 2 spacecraft into a geocentric escape hyperbola. The NASA tracking station at Johannesburg, South Africa, acquired the spacecraft about 31 minutes after launch. Solar panel extensions was completed approximately 44 minutes after launch. The Sunlock acquired the Sun about 18 minutes later. The high-gain antenna was extended to its acquisition angle of 72 degrees. The output of the solar panels was slightly above normal. As all subsystems were performing nominally, the battery was fully charged and the solar panels provided adequate power. The decision was made on August 29th to turn on cruise science experiments. On September 3rd, the Earth acquisition sequence was initiated and Earth lock was established 29 minutes later. The lack of accuracy of the Atlas Agena was such that a mid-course correction was required to make the flyby Venus. The mid-course correction consisted of a roll-turn sequence followed by a pitch-turn sequence and finally a motor burn sequence. Preparation commands were sent to the spacecraft at 21:30 UTC on September 4th. Initiation of the mid-course maneuver sequence was sent at 22:49 Universal Time, and the roll-turn sequence started 1 hour later. The entire maneuver took approximately 34 minutes. Here's the clip.
Tuesday afternoon, it is decided to go ahead with the trajectory correction. Goldstone engineers sent roll, pitch, and velocity commands to the spacecraft. The motor is fired and shuts off on time. Now we must wait. New tracking data will determine if the flight path has been corrected.
On September 8th, the spacecraft experienced a problem with attitude control. It automatically turned on the gyros and the cruise science experiments were automatically turned off. The exact cause is still unknown as attitude sensors went back to normal before telemetry measurements could be sampled, but it may have been an Earth sensor malfunction or a collision with a small unidentified object which temporarily caused the spacecraft to lose sunlock. A similar experience happened on September 29th. Again, all sensors went back to normal before it could be determined which axis had lost lock. On October 31st, another anomaly occurred. The output from one solar panel deteriorated abruptly. It was diagnosed as a partial short circuit in the panel. As a precaution, the cruise science instruments were turned off. A week later, the panel resumed normal function and cruise science instruments were turned back on. The panel permanently failed on November 15th, but Mariner 2 was close enough to the Sun that one panel could supply adequate power. Thus, the cruise science instruments were left active. Finally, on December 14, 1962, Mariner passed Venus at nearly 40,000 kilometers, collecting data and the current condition of the atmosphere of the planet. After the encounter, cruise mode resumed and the spacecraft entered the point in orbit closest to the Sun on December 27th at a distance of 105,464,560 kilometers. The last transmission from Mariner 2 was received on January 3, 1963, making the total time from launch to termination 129 days. Mariner 2 remains in a heliocentric orbit. Now, some scientific results provided by Mariner 2. Along its flight through interplanetary space and during the flyby of Venus, Mariner 2 made some important discoveries. Mariner discovered that Venus has a slow rotation rate in the opposite direction of Earth's rotation. Venus's surface temperature is hot. Mariner measured temperatures between 490 and 595 degrees C. Venus has a predominantly carbon dioxide atmosphere with continuous cloud cover up to 60 kilometers above the surface. Venus has very high surface pressures and no detectable magnetic field. It was also shown that in interplanetary space, the solar winds stream continuously, and the cosmic dust density is much lower than the near-Earth region. Mariner 2 also provided an improved estimate of Venus's mass as well. Public reaction to Mariner's success was very positive.
The public reaction to the technical achievement was enormous. For the first time, the United States could point to its first in the race for space. It is a proud time for the U.S., Time magazine proclaimed. No achievement by a Russian cosmonaut or U.S. astronaut, no experiment made by any of the myriad other satellites that have been shot aloft has taught man nearly so much as the improbable voyage of Mariner 2. William Pickering found himself featured on the cover of Time. Pasadena honored the JPL director by naming him Grand Marshal of the Tournament of Roses Parade. NASA arranged for Pickering and his management team to meet John Kennedy at the White House. In the Oval Office, they presented the president with a model of the spacecraft. 20 days after passing Venus, Mariner 2 transmitted half an hour of telemetry and then went silent. Today, the spacecraft is a mute piece of metal that endlessly circles the sun. But inside the spacecraft's thermal blanket is a small American flag, secretly placed aboard against official wishes, as a patriotic act to honor the very first in space for the United States.
After 5 years of playing catch-up to the Soviet Union, the U.S. flew the first successful robotic encounter with another planet. The Mariner 2 spacecraft ushered in a new era of solar system exploration. And now let's turn our attention to the satellite known as Relay 1. Along with passive communication satellites like Echo 1, NASA planned a modest low-altitude active satellite project for the early 1960s. The Department of Defense had responsibility for synchronous orbit satellite systems under Project Advent, so NASA confined its research and development activities to low and medium altitude communication satellites. In November 1960, NASA awarded a contract to Space Technology Laboratories for a feasibility design study for an active communication satellite, and by the following January, officials were briefing industry on the agency's requirement for Project Relay. As a result of the Soviet Union's, quote, space spectaculars, end quote, of 1961, and President John F. Kennedy's subsequent support of a strong U.S. space program, NASA's communication satellite program received supplementary funds that made it feasible to support active satellite research. In May 1961, the Radio Corporation of America, RCA, was awarded a contract to fabricate 3 Relay satellites. Relay was designed with 3 objectives in mind. First, to test transoceanic communications. Second, to measure radiation in its orbital path. And third, to determine to what extent these high and low energy electrons and protons would damage the satellite's solar cells and diodes. The Relay satellites were built with redundance as a major feature. They carried 2 sets of every major system of circuits. Relay's most important component, the microwave repeater, received frequency-modulated signals from 1 or 2 ground stations, amplified these signals, and retransmitted them. To coordinate and define Relay's main international experiments, and an international ground station committee was formed. Relay 1 weighed 170 kilograms. It was 33 inches high and 29 inches in diameter. It sort of resembled a corkscrew. The exterior was covered with 8,215 solar cells. The launch vehicle for Relay 1 was a Thor Delta, very similar to the launch vehicle used for Echo 1, Ariel 1, and Telstar 1. On December 13, 1962, Relay was successfully launched into an elliptical orbit with a period of 185 minutes. Relay 1 was spin stabilized. It had an initial spin rate of 167.3 RPMs and an initial spin axis orientation with a declination of minus 68.3 degrees and a right ascension of minus 56 degrees. Shortly after launch, two basic problems evolved. One was the satellite's response to spurious commands, and the other was an abnormal power drain on its storage batteries. The power problem was traced to a voltage regulator in a transponder. A second transponder was used as backup, and the mission went on as planned after a 2-week delay. And by March 1963, Relay 1 had fulfilled its mission objectives. On April 9, 1963, Relay transmitted live television signals from the United States to Great Britain for Winston Churchill's honorary U.S. citizenship ceremony. On November 22nd of 1963, Relay 1 became the first satellite to broadcast television from the U.S. to Japan. The first broadcast occurred during orbit 2677. It was supposed to be a pre-recorded address from the President of the U.S. to the Japanese people, but was instead the announcement of John F. Kennedy's assassination. On orbit 2678, the satellite carried a broadcast titled Life of the Late John F. Kennedy. This became the first television program broadcast simultaneously in the U.S. and Japan. In later orbits, NBC transmitted coverage of the funeral procession from the White House to the Cathedral. In the 3 days following the Kennedy assassination, Relay 1 handled a total of 11 spot broadcasts, 8 to Europe and 3 to Japan. All the useful passes of the satellite were made available to permit immediate coverage of the tragic events. In August of 1964, Relay 1 was used in tandem with CENTCOM-3 to broadcast portions of the 1964 Summer Olympics from Tokyo. The signal that originated in Tokyo was transmitted to CENTCOM-3, and CENTCOM-3 transmitted it to Relay 1, and Relay 1 transmitted it to the U.S. and Europe. This was the first time that two satellites were used in tandem for a television broadcast. Some have said that Relay 1 worked too well. It would not respond to commands to turn itself off and continued relaying signals until February 1965, when communication was lost. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.